Our lesson 4 for chapter 1 is about vector. What is a vector? A vector is any physical quantity that requires both a magnitude and a direction for its complete description. Examples of vectors encountered in statics are force, position, and moment. A vector is shown graphically by an arrow. The length of the arrow represents the magnitude of the vector, and the angle theta between vectors and the fixed axis defines the direction of its line of action. The head or tip of the arrow indicates the sense of direction of the vector. As we can see here in the figure, this vector A here is directed to quadrant 1 if this is the origin, and this is the location of the tail, and this is the head. So in here, the head indicates that the vector is directed 20 degrees from the positive x-axis. And if this is the distance 1, so as we can see here, we have here 1, 2, 3, 4. So meaning this vector here is 4 units directed 20 degrees from the horizontal. So in rectangular system, we are expressing the force. We're expressing the force F as the magnitude of the x and the y. So that is in terms of the components. If this is the force F here, then this is the x component and the y component. While in the vector, we are expressing this as the radius vector, and the direction. So in this case, it is 4 units directed 20 degrees from the horizontal. In print, vector quantities are represented by boldface letters such as A, and the magnitude of the vector is italicized. So this is the magnitude of the vector. No? So, kung titingnan natin dito, this A here is the name of the vector, no? Which represents vector A, while this italicized A here represents the magnitude of the vector. For the handwritten work, it is often convenient to denote a vector quantity by simply drawing an arrow above A. So, if we say vector A, so we can just say that's vector A. Kasi hindi naman natin siya ma-represent yung A as a boldface letter, no? If we are doing it in drawing or kapag handwritten yung gamit natin. Now let us talk about the vector notation of a force, or the rectangular representation of a force. So the force F is just equal to F multiplied by the lambda. And what is lambda? Lambda is a unit vector. There are two cases in determining the lambda, or the unit vector. First, by direction cosines, and second, by using the coordinates of any 2 points on the line of action of the force. So if we are given the direction cosines, we can say that the lambda is just equal to cosine theta x I plus cosine theta y j plus cosine theta z k. I, j, k ay tumutukoy sa direction, no? Wherein si I is for the x direction, si j is the component along the y direction, and k is the component along the k direction. So if we are given any 2 points, per se we have point 1 with the coordinate of x sub 1 comma y sub 1 comma z sub 1. So if this is point 1 and it has the coordinates of x 1 comma y 1 comma z 1, and this is another point here point 2 with the coordinate of x sub 2 comma y sub 2 comma z sub 2. And this point 1 and point 2 here, of course, is along the line of action of the force. Now, if we are using the coordinates, we have here the x direction referred to the difference between x sub 2 and x sub 1. And of course, that is the dx, or the distance x. And the y here is the difference between y sub 2 and y sub 1, and this is the dy. While the z is the difference between z sub 2 minus z sub 1. And with this, the unit vector is equal to 1 over d multiplied by the quantity dxi. So this dx here is along the I direction, and this y here is along the j direction, and this z here is along the k direction. Now, what is the value of the d? D is the diagonal, or it is the distance between the 2 points. If we have the vector having the 2 points, the points on the tail and the point on the head, so that distance is just equal to the distance formula, that is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared plus z sub 2 minus z sub 1 squared. How about the direction cosines? For the direction cosines, for the cosine of theta x, that is just equal to dx over diagonal. And for the cosine of theta y, that is equal to dy over diagonal. Cosine theta z, that is just the dz over d. The cosine squared of theta x plus the cosine squared of theta y plus the cosine squared of theta z is equal to 1. And from this, we know that the cosine of theta x is just equal to dx over d, no? The same to the cosine theta y, that is dy over d, and the cosine of theta z is dz over d. Now, substituting the value here, and we have here the dx over d squared plus the dy over d squared plus dz over d squared is equal to 1. And we should also note that for the components, the fx is just equal to f multiplied by cosine theta x. The fy is equal to f cosine theta y, and the fz is equal to f cosine theta z. And if we are going to compute for the magnitude of the force F, that is just equal to the square root of fx squared plus fy squared plus fz squared, wherein this fx, fy, and fz are the components of the force F. And if we are going to make use of the slope, since the cosine of theta x is equal to dx over d, then we could say that this is equal to f, the cosine of theta x we'll replace that to dx over d. For the fy, that is f, that's dy over d. And for the xz, that's f multiplied by dz over d. So for the rectangular representation of this vector f here, we can say that f is equal to f multiplied by, so that is just the sum of these components here. So that's cosine of theta x to be multiplied by the unit vector in the direction of x, that is the I. And for the y component, we have the f cosine of theta y to be multiplied by the unit vector in the direction of y, that is j. Plus the z component, so that's f cosine of theta z to be multiplied by the unit vector in the direction of z axis, and that is the k. So simplifying this, we have f, since common yung f sa lahat, to be multiplied by cosine theta x I plus cosine of theta y j plus the cosine of theta z times k. But from here, we have the cosine of theta x is just dx over d, the theta y is dy over d, and the cosine of theta z is dz over d. So using the slope, this can be expressed as f for the cosine theta x, that is dx over d, multiplied by the unit vector I, plus for the cosine theta y, that's dy over d, multiplied by the unit vector j, plus the cosine theta z, that is the dz over d. So we have here dz over d to be multiplied by the unit vector k. So this is how we are going to do the rectangular representation of the force. And if we are going to make use of the angle, we are going to make use of this formula here. And if we are going to make use of the slope, then we will be using this. If we are going to simplify this in terms of the components, we can say that the force is just equal to the x component times I plus the y component times j plus the z component times k. Now, this is true for the 2D and the 3D. What is the difference between them is, if we will be having a two-dimensional coordinate axis, then we will just drop this third term here. So, kapag 2D lang, ang makikita lang natin doon ay si I at saka si j. No? So, that's just fxi and the fyj. And if 3D na yung given, then magkakaroon na tayo ng third component wherein that is the third component sa along the z-axis. So our problem number 1 for the rectangular representation of a force, we are asked to determine the x and the y components of the force as shown in the figure using the rectangular representation. So from here, we have the F1 is equal to 58 kilonewton with an angle of 30. So we are asked to compute for the x and the y components of each forces here. So for each force, that is just equal to fx times I plus Fy times J. As we can see from the force 1 and the force 2 here. So for the force 1, we have this x component, F1x here. And this is the y component of the F1. And this is the F1x. No? Since the F1x is adjacent of the 30 degrees here, we can say that for F1, so we have F1 is equal to Fx, that's the x component, that's F1 cosine of 30, since this is adjacent side of the 30 degrees. So we have here F1 cosine of 30 degrees times I plus the F1y, so that's F1, the y component is opposite of the 30 degrees, so that's sine of 30 degrees times the component j. Now, since common yung F1, so we can say that F1 is equal to 58 kilonewton multiplied by cosine of 30i plus sine of 30j. So, computing for this, we have for the x component, that's 58 cosine of 30 degrees, and that is equal to 50.23. So we have here 50.23i, and for the y component, we have 58 sine of 30, and that is equal to 29. So we have here plus 29j. So this is the answer for the rectangular representation of the force F1. Now, let us proceed to F2. So for F2, we have 50 kilonewton directed to quadrant 2 with an angle of 45 degrees. So for this, for the x component, so this is the F2x, and for the y component, this is the F2y. Now, expressing this in terms of the rectangular representation, so we have F2 is equal to F2 for the x component, that is adjacent side of 45 degrees. So we have here cosine 45 degrees multiplied by the unit vector I plus the F2, the y component, that would be multiplied by the sine of 45 degrees. And we have here the unit vector j. F2 is equal to 50 kilonewton. So we have here F2 is equal to 50 kilonewton multiplied by cosine 45 I for the x component and sine 45 for the y component. But we have to consider the sign since directional ito, no? So as you can see here, the F2x is directed to the left, so meaning the x component is negative. So this will be considered as negative here, and we have negative in the x component. The component, so we have 50 cosine 45 is equal to 35.36. We have here F2 is equal to negative 35.36i, and since the sine 45 is just equal to the cosine 45, so we have here plus 35.36j, and this is the answer for the rectangular representation of the force F2. How about for the F3? So for F3, we have here F3 is equal to, since as we can see here, F3 has both the negative x component, this is F3x, and the negative y component, F3y, since this is directed to quadrant 3, so it has the negative x and the y component. So for the x component, that is just equal to negative F3, since we are using the slope, no? So we are going to compute for the diagonal, since given is the slope of 12 rise and 5 run. So for the diagonal, that is just square root of 12 squared plus 5 squared, and we have here 13. So we have here the diagonal of 13. And for the x component, we are going to multiply this with the x 5 over the diagonal 13. And minus F3 for the y component, that will be 12 over the diagonal 13. And we have here for the x component, so we have the unit vector I, and for the y component, we have the unit vector j. So we have here F3 is equal to, since F3 is equal to 45 kilonewton, multiplied by negative 5 over 13i, and we have here minus 12 over 13j. So computing for this, we have F3 is equal to 45 times 5 over 13. Hindi ko na sinamba yung negative. That's 17.31. So it's negative 17.31 I. And for the y component, we have here 45 times 12 over 13, and that is equal to 41.54. So we have minus 41.54 J. And this is our answer for rectangular representation of the force 3. Now for F4, as we can see here, F4 is purely horizontal to the right. That's 40 kilonewton. So it has only x component. So we can say that F4 is just equal to 40 kilonewton I, since it has only x component, it does not have the y component. And this is our answer for F4. So for the units, since we are in kilonewton, so force 1 is kilonewton and force 2 is kilonewton, so everything is expressed in kilonewton. We are going to make use of the calculator in order for us to solve for this rectangular representation of the vectors here. So what we are going to do is to make use of the mode and complex. So for the first one, as we can see here, that is 30 degrees. No, that is 58 kilonewton with an angle of 30 degrees. So we have here 58 angle of 30. And that is equal to 50.23. So this 50.23 here is your I, no? And this 29 is your J. So as we can see here, we have 50.23 I plus 29J for the first one. For the first two, we are going to express this in terms of the standard angle. So this is equal to 180 degrees minus 45 degrees, since here is 45 degrees. So 50 angle, for the angle, that is 180 minus 45. And we have here negative 35.36i and plus 35.36j. How about for force 3? For force 3, we cannot directly use this since force 3 is expressed in terms of the slope. So the first thing that we are going to do is to express this in terms of the angle. If we are going to compute for the angle, since we have here angle theta, now so the opposite is 12 and the adjacent is 5. So if we are going to compute for the angle theta, that is equal to opposite over adjacent. So computing for theta, that is this arctan of 12 over 5. So we have here arctangent of 12 divided by 5. And that is equal to 67.38 degrees. So we have here 67.38 degrees. Now, so, since standard angle yung kailangan natin dito, so for the standard angle, that is just equal to 180 degrees plus this theta here. So, computing for this, we have the magnitude of 45 kilonewton, angle, that's 180 plus theta, which is 67.38 degrees. And we have here negative 17.31i and negative 41.54j. And of course, for the F4, kahit hindi natin gagamitan ng calculator, your F4 is equal to 40i since it has only the x component and wala siyang